There are so many stars and planets in the universe that it is impossible to know their exact number. In addition, no matter how many of them there are, their size and weight will never be repeated. But there are stars, planets and other bodies very close in weight and size. One of them is the planet Vinera, which is called the twin of the Earth. Venus is the second planet from the Sun and a metal planet with a very dense atmosphere. The pressure of Venera's atmosphere is 92 times higher than the pressure of air at sea level of our planet. Conditions on the surface of Venus are very different from those on Earth, as its dense atmosphere is 96.5% carbon dioxide, with most of the remaining 3.5% nitrogen. The surface pressure is 9.3 megapascals. Vinera is 12,103 km in diameter, 638 kilometers, less than the diameter of our planet, and its mass is 81.5% that of Earth, making it the third smallest planet in the solar system. Vinera is one of the 4 inner planets in the solar system, with an average distance of 108 million kilometers from the Sun, and it took 224.7 Earth days for Vinera to orbit the Sun. Vinera moves at a speed of 6.5 kilometers per hour at the equator. Therefore, one solar day of Vinera is equal to 116 Earth days. Most planets in the solar system rotate counterclockwise on their axis, but Venus spins clockwise in a retrograde rotation once every 243 Earth days, the slowest rotation of any planet. For an observer on the surface of Vinera, the Sun rises in the west and sets in the east, but the thick clouds of Vinera prevent the Sun from being seen from the surface of the planet. This means that the Venusian sidereal day lasts longer than the Venusian year. Due to the strong atmospheric flow, the length of the day varies by up to 20 minutes. There are many reasons why Venera's sidereal day is so long, one of which is Venera's proximity to the Sun. A balance between tidal locking to the Sun's gravity and atmospheric flow generated by the Sun's heating of the thick Venusian atmosphere can be demonstrated. At the same time, Venus' rotation may have slowed down over billions of years due to the wobbles of neighboring planets and other gravitational effects. Vinera has an average orbital speed of 35 km per second and an ecliptic declination of 3.86 degrees. Because of this, there is almost no change of seasons in Vinera. Venera's surface is 460 million square kilometers, and this figure is equal to 90.2% of the size of our planet. The density of Vinera is very close to that of our planet. Earth's density is 5.515 grams per cubic centimeter, and Venera's density is 5.243 grams per cubic centimeter. Vinera has a gravity of 90.4 of our planet. Vinera is the third largest celestial body after the Sun and the Moon. The carbon dioxide-rich atmosphere creates the strongest greenhouse effect in the solar system, and because of this, Venera's surface temperature is at least 462 degrees centigrade. This makes Venera's surface hotter than Mercury's, even though Venus is almost twice as far from the Sun as Mercury, and thus Mercury can only absorb about 25% of the Sun's radiation. Due to the greenhouse effect, Vinera absorbs solar radiation differently, just like on Earth, but the carbon dioxide in our planet's atmosphere does not exceed 1.5%, instead of 96.5%, as in Venera's atmosphere. In Venera's atmosphere, there are chemical compounds of gases other than carbon dioxide and nitrogen, such as sulfur dioxide, water vapor, carbon monoxide, argon, helium, neon, as well as traces of oxygen, carbonyl sulfide, hydrogen chloride, and hydrogen fluoride. Above the dense carbon dioxide layer there are thick clouds, composed mainly of sulfuric acid, which form sulfuric acid hydrate as a result of the chemical reaction of sulfur dioxide and water. In addition, the composition of clouds includes iron chloride, iron sulfate, aluminum chloride, and phosphoric anhydride. These clouds, similar to a thick cloud cover on Earth, reflect about 70% of the sunlight that falls on them back into space, and because they cover the entire planet, they prevent visual observation of Venera's surface. The constant thick cloud covering the entire surface of the planet means that even though Venus is much closer to the Sun than Earth, the surface of the planet receives less sunlight. Only 10% of the incoming sunlight reaches the planet's surface, resulting in average surface daylight. It can be compared to a thick cloudy day on our planet. Venera's average orbital speed is 35 kilometers per second. Orbital velocity decreases with distance from the Sun, except for the planet Uranus. For example, the average orbital speed of Mercury is 47 kilometers per second. The average orbital speed of Venus is 35 kilometers per second. The average orbital speed of Earth is 30 kilometers per second. The average orbital speed of Mars is 24 kilometers per second. The average orbital speed of Jupiter is 13 kilometers per second, and the average orbital speed of Saturn is 9.6 kilometers per second. Kilometers. And of course the exception is that Uranus has an average orbital velocity of 24 kilometers per second. And Neptune's speed decreases greatly if we follow the scale of decreasing orbital velocity as it moves away from the Sun. Neptune's average orbital speed is 5.4 kilometers per second. During the rotation of Venus in its orbit, the distance between the two planets is reduced to 38 million kilometers when it is closest to our planet, and when Venus is furthest from our planet. The distance between these two planets is 261 million kilometers. In addition, Vinera is the closest planet to our planet, and therefore, on some dark nights, faint rays of light from Vinera fall on the surface of our planet. To the naked eye, Vinera appears as a point of white light, brighter than any other planet or star other than the Sun. The planet is bright enough to see during the day, but is easier to see when the Sun is low on the horizon or setting. As an inferior planet, it is always around 47 degrees from the Sun. As Venus orbits the Sun, it passes the Earth every 584 days. Thus it changes from an evening star seen after sunset to a morning star seen before sunrise. Of course, this planet, which is called the twin of our planet, accompanies us a lot even if we don't notice it.